Welcome to Talk Tensors, your shortcut to understanding cutting-edge machine learning research. Today, we're diving deep into a pretty significant paper.
Oh, yeah. Which one?
It's called RSA. Replace anyone, say anything. A training-free framework for audio-driven and universal portrait video editing.
Ah, RSA.
Wow.
Right. Very interesting stuff.
Yeah, exactly. The whole idea of seamlessly editing portrait videos, changing who's speaking or maybe the words they're saying, it's getting really important.
Definitely. Think e-commerce,
Yeah.
gaming.
Even just quick fixes for content, right? But a lot of the current ways, well, they're a bit limited.
So,
Often just focusing on the mouth area or, needing tons of training for specific things. And sometimes they struggle with keeping the person looking consistent if you change them.
exactly. That's where this RSO paper comes in. It proposes a genuinely novel approach because it's a training-free framework.
That's the big hook, isn't it? Training free.
It really is. Significant departure.
Yeah.
RSA aims to be this sort of universal solution for editing portrait videos.
So it can handle both how someone looks and what they're saying.
Yep, either separately or together. And crucially, without needing to train up specialized models for every little task.
Okay, let's unpack the core of this. The innovation seems to be around something called Unified Animation Control, UAC.
That's the one, UAC.
So how does that work? They mention using source inversion latents. Now, for our listeners maybe not deep in the ML weeds, what are those, basically?
Good question. Think of latents as like a highly compressed digital representation, almost like a very detailed blueprint of the original video.
Okay, a blueprint. I like that.
And RSO uses this blueprint to control the key parts of the edited video.
Like the person's appearance, their movements.
Exactly. And how their lips sync up with the audio, plus keeping the motion smooth frame to frame.
And what's really clever, it seems, is how adaptable it is.
Yeah, that's a neat part. You can tweak the editing just by adjusting the very first frame, the initial reference image.
So change the head pose or the expression in that first picture.
And RSA can then carry those changes consistently through the whole video.
Yeah.
It's quite an intuitive way to guide the edit.
Makes sense. So our goal here is to really dig into how this RSA architecture actually pulls this off and, understand where it fits in the whole story of portrait animation tech in machine learning.
Sounds like a plan.
Yeah.
Let's get into the context.
Right. So the paper itself kicks off by defining portrait animation, basically making lifelike videos from just a single photo, right? Driven by other videos or audio.
Yeah, the classic setup.
But a lot of the earlier work in this space, it seems, was more focused on generating videos from scratch, making them look natural, getting the motion right.
Image to video generation, essentially.
Exactly. RSA, though, tackles something slightly different and maybe more practically useful, which is editing existing videos.
That's a crucial distinction, yeah. Think traditional photo editing versus like generative art creating something totally new.
Good analogy.
And in video, this editing capability is just vital for efficiency in the real world. Imagine you need to quickly update, say, training videos or tweak dialogue in a virtual presentation.
Without re-recording the whole thing from scratch.
Precisely. The authors are right on the money identifying this growing need. And RSA aiming for a training-free solution. That directly tackles the practical pain points of adapting existing videos.
Right. And the main goal, like they state, is this training-free way to change either the person's identity or the words they're saying.
Or both at the same time.
Or both. And they emphasize, that audio and video are these complex streams of information over time, lots of relationships within frames and between frames.
Which is what makes good portrait video editing such a challenging ML problem, fundamentally.
Definitely. The paper then sorts existing methods based on how well they adapt to different inputs, audio, visual cues, both without needing retraining, zero-shot adaptation, they call it.
And they critique the existing audio-driven methods pretty well.
Yeah, pointing out they often just focus narrowly on the lips.
Right. And the key insight there is, okay, the lips might sync, but the rest of the face, it can look weirdly frozen or just have random distracting twitches when there's no speech.
Visual leakage, they call it sometimes.
Or just poor audio-visual sync beyond the mouth. It shows these methods maybe don't fully grasp how complex the audio-visual link is for the whole face.
And then on the visual side, methods using key points or facial landmarks.
Those have their own issues, often need specialized training just to detect the key points accurately. Plus, they can be really sensitive to differences in the person's face head shape features.
And they often ignore the background too, right? Which can look weird.
Exactly. Leads to inconsistencies, less realistic edits overall.
So what's fascinating about RSA is how it tries to get around these problems. It's not just lips, not just key points.
No, it aims for more flexible cross-modal tasks, handling audio and visual drivers together more holistically.
And a key piece of the tech is this DDIM inversion.
Right. That's rooted in diffusion models. Think of it as a clever way to sort of undo the noise-adding part of diffusion.
Allowing you to make very specific changes.
Exactly. To inject targeted information and guide the editing. RSA uses this for attention injection via these things called perturbations.
Okay, so the absolute core innovation is this unified animation control, UAC.
Of course.
3 parts.
Yep. Shape control, speaking control, and temporal consistency control.
Let's break those down. Shape control. That's about keeping the person looking like themselves, right? Maintaining the structure.
Precisely. Keeping the appearance balanced. The idea comes from an observation, actually, from another paper, Massacrol.
Oh, yeah. What did they observe?
That the self-attention mechanisms, specifically the queries in these deep learning models, are really important for defining the overall layout of objects in an image.
Interesting. So RSA uses that insight.
Yeah. During the first few steps of denoising, remember, diffusion models build the image by removing noise bit by bit. RSA swaps the query part of the self-attention from the target video with the query from the source video.
Just the query, not the key as well.
It's just the query. They found that replacing only the query maintains that structural layout, that consistency, without messing up the original identity too much.
Ah, so it borrows the structural blueprint, but not the whole identity. Clever.
It is. It preserves the fundamental form, like you said.
Okay, next up, cross-modal speaking control, CSC. This must be where the audio meets the visuals for the lips and expressions.
Exactly. This is the crucial bit for linking what's said to how the face moves. It makes sure that relationship is coherent.
And how does RSA do that?
Similar idea.
Yeah.
During those initial denoising steps, it injects the visual query and the audio key from the source into the target pipeline.
Why those specific parts?
This helps create a more consistent mapping between the audio signal and the lip movements, the expressions. It lets the system adapt to different spoken words while keeping it looking natural and synced up.
So basically, realistic lip sync, whether you change the speaker or the dialogue.
That's the goal. It helps make sure if you put different words into the same person's mouth, the lip movements adjust correctly. Or if a different person says the same words, their lips move convincingly.
Got it. And the last piece, temporal consistency control, TCC.
Right. This is all about smoothness across time, making sure the edits flow naturally from frame to frame without weird jumps or jitters in the motion.
Always a challenge in a video. How's that achieved?
Again, similar mechanism. They replace the queries and keys of each target frame's temporal attention module with the corresponding ones from the source video.
So injecting the source video's frame-by-frame attention patterns.
Effectively, yes. It borrows the rhythm and flow of motion from the source to make the edited version feel more continuous and natural.
So these 3 controls, shape, speaking, temporal, they all work together, or can you use them individually?
Both. They can work individually or in combination, depending on the editing task. That's what gives it the versatility.
Right. The paper then digs deeper into the tech, especially DDIM inversion. You mentioned it's like undoing the diffusion.
Yeah, but it's important to understand, inverting a real image back into that perfect diffusion, latent space, isn't trivial. Real images don't always have a neat, noise-free representation there.
Okay, so it's an approximation.
DDIM inversion provides a pretty efficient way to approximate that reverse process. RSA builds on that. The real innovation is how they introduce very specific perturbations, like tiny targeted nudges during this inversion.
Guided by the edits you want to make.
Exactly. Guided by the audio stream for speech changes or the visual stream from a reference image for appearance changes. This lets them tweak specific things while keeping others stable.
And that first reference frame, the starting image, seems really crucial, especially for appearance edits.
Absolutely. They talk about different ways to manipulate that first frame to guide the whole process.
Like what?
Things like using face parsing and in-painting, basically. Cutting out the face and filling it in differently to swap the person but keep the background.
Okay.
Or using other methods to maybe synthesize a new head pose for that first frame, or even adjust how open the eyes or mouth are.
But they admit limitations, too.
Yeah, they do note that really fine-grained control over subtle expressions, slight eyebrow shifts, tiny eye movements, seeing teeth, clearly that's still a challenge. An area for future work.
Fair enough. Okay, let's talk experiments. How did they test RC?
They used the HDTF dataset. Pretty standard for these kinds of tasks. Video dubbing, talking heads.
And compared it against?
A bunch of relevant baselines. What two-lip, video retalking, talk-lip, DINet, muse talk,
Yeah.
names people in the field will recognize, each known for slightly different strengths.
And what were they measuring? What makes a good result?
Several things. Visual quality, obviously, does it look good?
Yeah.
Eidetic preservation, does the person still look like themselves? Or the target identity? And lip sync accuracy. How well do the lips match the new audio?
Using standard metrics?
Yep. FID and FVD for visual quality and temporal consistency. LPIPS for perceptual similarity. LSED and LSEC for audio lip sync quality. And a few others like NIKI and CSIM for cross-identity tasks.
And the results. How did RSA stack up?
Pretty compellingly, based on their quantitative results. Across the board, whether they're changing speech for the same person or swapping identities, RSA generally outperformed the baselines on those metrics. Better lip sync, better visual quality.
And qualitatively, the actual videos.
The visual comparisons in the paper really help. You can see RSA doing a better job preserving the overall shape and pose compared to something like DINet,
Okay.
and achieving more natural, better synced lip movements than, say, muse talk, especially in tricky cases.
Like when there's silence.
Exactly. Some methods tend to generate weird mouth movements, even with no audio, maybe due to that visual leakage we talked about. RSA seems more robust there, keeping the mouth realistically still.
And head rotation.
Also handled well. More visually coherent, more natural lip movements during turns compared to some others, thanks to that shape control and temporal consistency control working together.
What about the appearance editing results? Swapping faces.
They compared RSA against key point-based methods there, like Live Portrait and MegActor. The visuals suggest RSA gives broader consistency. It's not just matching key points. It seems to capture the overall head shape, hair, even clothes better, leading to more natural identity swaps.
So less uncanny valley.
Potentially. They show examples where Live Portrait has some lip blurring, and MegActor maybe doesn't quite capture the target identity as well as RSA does.
Interesting. And head rotation again.
Yeah, in Figure 5, they show RSA handling head rotation, and expression changes more naturally than Live Portrait, which can look a bit rigid, like it's just warping the face onto the pose. RSA seems to prioritize fluidity and realism more.
Okay, and they did ablation studies too, taking bits out to see what breaks.
Standard practice, yeah.
Mm-hmm.
Very important. They looked at the effect of the driving audio first,
What did they find?
that using the actual speech audio, rather than just random noise, helps preserve image details, much better background, clothing, etc., in both lip editing and appearance editing. Makes sense, right? More information.
Yeah, what about lip movement?
With real speech, the lips moved appropriately. With random noise driving it, the mouth just tended to hang open unnaturally in the lip editing task.
Shows the audio connection is working.
Definitely. Though they did note that handling both identity change and speech change simultaneously in appearance editing is still tough. Needs more research.
Okay, what else did the ablations show?
They looked at the injection steps for shape control and temporal control.
The tear cases, those control how much influence those modules have. Right?
Exactly. For shape control, injecting more source shape, higher teres, made the output look more like the source, as you'd expect.
And temporal control.
Higher head improved motion consistency and background detail preservation up to a point. They settled on specific values for these based on the results.
And the speaking control injection.
That was interesting. They showed in Table 3 that increasing tera initially helps video quality, FED, and audio-visual sync, LSE metrics.
But only up to a point.
Right. Push data too high, and the sync quality actually starts to drop again. Seems like injecting too much of the original lip information can interfere with adapting to the new audio. It's a balancing act.
Fascinating. So it really highlights the need for careful calibration of these different controls.
Absolutely. It's not just throwing everything together. It's about finding the right blend.
Okay, let's pull back a bit. How does this RSA work fit into the bigger picture, the history of this field?
Well, facial animation in computer graphics goes way back, right? From early manual stuff to model-based approaches.
Mm-hmm.
Deep learning obviously turbocharged everything, getting us way closer to photorealism.
But challenges remained.
Oh, yeah. Preserving identity consistently during motion transfer, getting really spot-on lip sync, these have been long-standing problems people have chipped away at for years.
And RSA's contribution?
I think its training-free nature is a really significant step in that history. Many previous top methods needed huge specific data sets and lots of training time.
Making them less accessible, less flexible.
Exactly. RSA follows this trend we're seeing elsewhere in generative ML, like in image editing with diffusion models, where these Training-free, more adaptable methods are gaining traction. Less data-hungry, more versatile, that's a key direction.
So boiling it down, what are the absolute key takeaways from RSA?
Okay, number one, it's versatile editing without needing tons of training data or task-specific models. Big plus.
Right.
Number two, the Unified Animation Control, the UAC module, is a neat, unified way to control shape, speech, and time using those inversion latents.
Okay.
3, it shows strong results for both lip sync and identity transfer, tackling known weaknesses of older methods.
Good.
4, editing that first frame gives intuitive control over pose and expression.
Nice feature.
And 5, the ablation studies really back up the contribution of each part of the UAC. It's well validated.
Excellent summary. Now, what about the real world? Where could this actually be used?
The potential impact is pretty substantial, I think. For content creators, imagine quickly tweaking existing videos, change the speaker, update a message but keep the person, or vice versa. Super efficient.
Saves reshoots.
Totally. Then virtual avatars, personalized communication, making them more expressive or adaptable. Accessibility too, think better video dubbing for different languages, keeping the original person's look.
Yeah, visually consistent localization would be huge.
Absolutely. And back to the examples you gave at the start. E-commerce demos, getting quick voiceover updates, game devs iterating faster on character dialogue and animation. Lots of possibilities.
Okay, great. Let's shift gears now to our novel notions segment. Where could this research lead next? Any speculative ideas?
Always fun to think about.
So RSA does a good job with lip sync and general expressions based on audio. What if? What if we push that further? More granular emotional control from the audio.
Ooh, interesting. Go beyond just what said to how it's said, capturing the emotional nuances.
Exactly. Imagine fine-tuning the tone, the prosody, happy, sad, sarcastic in the synthesized speech, and having RSA translate that not just into lip movements, but into really subtle facial expressions.
Like tiny eyebrow shifts, maybe muscle tension in the cheeks.
Yeah, that level of detail.
That definitely builds on the paper's foundation. They've already shown the audio-visual link. Future work could tap into advances in expressive text-to-speech synthesis. Those models are getting good at generating speech with different emotions.
So the challenge is mapping those richer audio features.
Pitch contours, speaking rate, intensity variations.
Yeah.
Mapping those to specific facial muscle activations. You might even draw on research into facial action units, FAUs, to get that really fine-grained expressive control in the video.
The impact could be huge, right? Virtual assistants that actually sound and look empathetic.
Or adaptive educational content, where the avatar's emotional delivery changes based on how the learner is doing. Huge potential.
Though ethical considerations there too, maybe. Manipulating perceived emotion.
Absolutely. Definitely something to keep in mind as the tech gets more powerful. Okay, what's your second idea?
All right, second notion. RSA is training free, using reference images and audio. What if we extended that training-free idea to allow more creative input, like user sketches or maybe even text prompts?
So instead of just swapping identities, a user could sketch a different nose shape?
Yeah. Or type, make the person look surprised. And RSA modifies the video accordingly, keeping the temporal consistency and lip sync if there's audio.
That's ambitious but intriguing. RSA's use of inversion latents. Maybe there's potential there to inject other kinds of guidance beyond just images or audio.
Connected to sketch-based generation or text-guided manipulation.
Potentially. It would involve bridging that gap between abstract user input, a sketch, text, and the low-level latent space manipulation. A significant technical challenge for sure.
But the payoff
Could be massive. Imagine empowering people with zero animation skills to do complex video edits, prototype character designs, create really personalized avatars just by sketching or describing them, democratizing video creation even further.
The challenge would be keeping it looking realistic, avoiding that uncanny valley, I guess.
Big time. Ensuring the edits blend seamlessly and look natural would be critical, but yeah, high potential impact if achievable.
Okay, standard disclaimer. These are just speculative ideas, folks, for entertainment and discussion.
Indeed. Fun to explore the possibilities.
So to wrap things up on RSA itself, really strong points are that training-free aspect, its universality, the versatile editing it enables.
Yeah, it's a really valuable contribution to portrait video editing research within ML. The UAC mechanism offers a sophisticated way to control different facets of the animation.
And the potential impact across different fields, as we discuss, is pretty clear.
Definitely opens up a lot of doors for applications and future research directions too, like they mentioned multi-language editing, handling bigger identity differences.
We definitely encourage listeners to check out the paper links in the show notes for the full technical dive.
It certainly leaves you thinking, doesn't it, about the future of video editing and that fascinating, ever-shifting balance between powerful automation and human artistic control.
A perfect thought to end on. Thanks for tuning in to Talk Tensors.